Hello students, welcome to the class on prototyping and types of prototyping. The objective of this session is to orient you towards the rapid development tools like CASE, which we called computer aided software engineering, to study prototyping, to study various types of prototyping, to study rapid development tools like CASE, and to study various advantages and disadvantages of computer aided software engineering. Let us start with the introduction. As we have seen, prototyping consists of building an experimental system rapidly and inexpensively for end user to interact with and evaluate. The prototype is refined and enhanced until users are satisfied that it includes all of their requirements and can be used as a template to create the final system. Prototyping encourages end user involvement in systems development and iteration of design until specifications are captured accurately. Approved prototypes serves as template for final system. This is the diagram of prototyping model, in which it starts with the communication. Then once we communicate, we have to quick plan, which is nothing but quick planning stage. Once we planning, then we have to modeling. The modeling is the stage in which we have to quickly design the system. Once we design, then construction of prototype, and once we construct it, then we have to deployment and delivery and taking the feedback how that system has been done. And once getting the feedback from the user, again we have to do the same cycle. This is the prototyping model. Let us see steps of prototyping. First step is to identifying users' basic requirements. Once we getting the requirement, then we have to developing an initial prototyping. Once we develop an initial prototype, then we have to use prototyping. Once we use that prototype, then we have to revising and enhancing prototype. Let us see some of the types of prototyping. The first type of prototyping is throwaway prototyping, also called close-ended prototyping. Throwaway or rapid prototyping refers to the creation of a model that will eventually be discarded rather than becoming part of the final delivered software. After preliminary requirements gathering is accomplished, a simple working model of the system is constructed to visually show the users what their requirements may look like when they are implemented into a finished system. Rapid prototyping involved creating a working model of various parts of the system at a very early stage after a relatively short investigation. The method used in building it is usually quite informal, the most important factor being the speed with which the model is provided. The model then becomes the starting point from which users can re-examine their expectations and clarify their requirements. When this has been achieved, the prototype model is thrown away and the system is formally developed based on the identified requirements. The most obvious reason for using throwaway prototyping is that it can be done quickly. If the users can get quick feedback on their requirements, they may be able to refine them early in the development of the software. Making changes early in the development life cycle is extremely cost effective, since there is nothing at that point to redo. If a project is changed after a considerable amount of work has been done, then small changes could require large efforts to implement, since software systems have many dependencies. Speed is crucial in implementing a throwaway prototype, since with a limited budget of time and money, little can be expanded on a prototype that will be discarded. Strength of throwaway prototyping is its ability to construct interfaces that the users can test. The user interface is what the user sees as the system, and by seeing it in front of them, it is much easier to grasp how the system will work. The second type of prototyping is evolutionary prototyping. In evolutionary prototyping, also known as breadboard prototyping, is quite different from throwaway prototyping. The main goal when we using evolutionary prototyping is to build a very robust prototype in a structured manner and constantly refine it. The reason for this is that the evolutionary prototype, when built, forms the heart of the new system, and the improvements and further requirements will be built. When developing a system using evolutionary prototyping, the system is continually refined and rebuilt. Evolutionary prototyping acknowledges that we do not understand all the requirements and builds only those that are well understood. Evolutionary prototypes have an advantages over throwaway prototypes in that they are functional systems, although they may not have all the features the users have planned. They may be used on an interim basis until the final system is delivered. In evolutionary prototyping, developers can focus themselves to develop parts of the system that they understand instead of working on developing a whole system. Third one is a incremental prototyping. The final product is built as separate prototypes. At the end, the separate prototypes are merged in an overall design. By the help of incremental prototyping, we can reduce the time gap between user and software developer. Fourth one, extreme prototyping. Extreme prototyping as a development process is used especially for developing web applications. Basically, it breaks down web development into three phases, each one based on the preceding one. The first phase is a static prototype that consists mainly of HTML pages, which we called hypertext markup language pages. In the second phase, the screens are programmed and fully functional using a simulated service layer, and in the third phase, the services are implemented. The process is called extreme prototyping to draw attention to the second phase of the process, where a fully functional user interface, which we called UI, is developed with very little regard to the services other than their contract. Let us see advantages. There are many advantages to using prototyping in software development. First advantage is reduce time and cost. Prototyping can improve the quality of requirements and specifications provided to developers because changes cost exponentially more to implement as they are detected later in development. The early determination of what the user really wants can result in faster and less expensive software. Second, improved and increased user involvement. Prototyping requires user involvement and allows them to see and interact with a prototyping, allowing them to provide better and more complete feedback and specifications. The presence of the prototype being examined by the user prevents many misunderstandings and miscommunications that occur when each side believes the other understands what they said. Since users know the problem domain better than anyone on the development team does, increased interaction can result in a final product that has greater tangible and intangible qualities. The final product is more likely to satisfy the user's desire for look, feel and performance. Let us see disadvantages of prototyping. Using or perhaps misusing prototyping can also have disadvantages. First, insufficient analysis. The focus on a limited prototype can distract developers from properly analyzing the complete project. This can lead to overlooking better solutions, preparation of incomplete specification, or the conversion of limited prototypes into poorly engineered final projects that are hard to maintain. Further, since a prototype is limited in functionality, it may not scale well if the prototype is used as the basis of a final deliverable, which may not be noticed if developers are too focused on building a prototype as a model. Second, user confusion of prototype and finished systems. Users can begin to think that a prototype intended to be thrown away is actually a final system that merely needs to be finished or polished. They are, for example, often unaware of the effort needed to add error checking and security features which a prototype may not have. This can lead them to expect the prototype to accurately model the performance of the final system when this is not the intent of the developers. User can also become attached to features that were included in a prototype for consideration and then removed from the specification for a final system. If users are able to require all proposed features be included in the final system, this can lead to conflict. Third, developer misunderstanding of user objectives. Developer may assume that users share their objectives, for example, to deliver core functionality on time and within budget, without understanding wider commercial issues. For example, user representatives attending enterprise software, for example, PeopleSoft, events may have seen demonstration of transaction auditing, where changes are logged and displayed in a difference grid view without being told that this feature demands additional coding and often requires more hardware to handle extra database access. User might believe they can demand auditing on every field, whereas developers might think this is feature creep because they have made assumptions about the extent of user requirements. If the developer has committed delivery before the user requirements were reviewed, developers are between a rock and a hard place, particularly if user management derives some advantage from their failure to implement requirements. Fourth, developer attachment to prototype. Developers can also become attached to prototypes they have spent a great deal of efforts producing. This can lead to problems like attempting to convert a limited prototype into a final system when it does not have an appropriate underlying architecture. This may suggest that throwaway prototyping rather than evolutionary prototyping should be used. Fifth, excessive development time of the prototype. A key property to prototyping is the fact that it is supposed to be done quickly. If the developer loses sight of this fact, they very well may try to develop a prototype that is too complex. When the prototype is thrown away, the precisely developed requirements that it provides may not yield a sufficient increase in productivity to make up for the time spent developing the prototype. Users can become stuck in debates over details of the prototype, holding up the development team and delaying the final product. Now, let us see the rapid development tools, which is rapid application development, which we also called as a RAD. Rapid application development is both a general term used to refer to alternatives to the conventional waterfall model of software development, as well as the names of James Martin's approach to rapid development. In general, rapid application development approaches to software development put less emphasis on planning tasks and more emphasis on development. In contrast to the waterfall model, which emphasizes rigorous specification and planning, rapid application development approaches emphasize the necessity of adjusting requirements in reaction to knowledge gained as the project progresses. This causes rapid application development to use prototypes in addition to or even sometimes in place of design specifications. Rapid application development approaches also emphasize a flexible process that can adapt as the project evolves rather than rigorously defining specification and plans correctly from the start. In addition to James Martin's RAD method, which is Rapid Application Development method, other approaches to rapid development include Agile methods and the spiral model. Rapid application development is especially well suited, although not limited to, developing software that is driven by user interface requirements. Graphical user interface builders are often called rapid application development tools. Let us see case, which is computer aided software engineering, is use of a computer assisted method to organize and control the development of software, especially on large complex projects involving many software components and people. Using case allows designers, code writers, testers, planners and managers to share a common view of where a project stands at each stage of development. Computer aided software engineering also help ensure a disciplined, check pointed process. Advantages of computer aided software engineering tool: it help standardization of notations and diagrams. It also help communication between development team members. It automatically check the quality of the analysis and design model. Reduction of time and effort. It enhance reuse of models or model components. Let us see some of the disadvantages of case tool. The first disadvantage is limitations in flexibility of documentation. It may also lead to restriction to the tool's capabilities. Major danger: completeness and syntactic correctness does not mean compliance with requirements. Cost associated with the use of the tool, that is purchase plus training. So, these are the various advantages and disadvantages. Let us come to the conclusion. Computer aided software engineering is the domain of software tools used to design and implement applications. Computer aided software engineering tools are similar to and were partly inspired by computer aided design tools used to design hardware products. Computer aided software engineering tools are used to develop software that is high quality, defect free and maintainable. Students, with this I would like to conclude by mentioning that we have finished discussing about what is prototyping, rapid development tool, computer aided software engineering and studied different types of prototyping. We have also studied various advantages and disadvantages of prototyping and computer aided software engineering. With this, I would like to conclude this session. Thank you.